Okay, in this short video, I'm going to cover some factoring hints and factoring examples. Now, I know that factoring is one of the biggest weaknesses for a lot of students, whether you're in elementary school, middle school, high school, or even college. Factoring always seems to be a problem. So, if you can remember some of these little hints, it might help your factoring days seem a little less wonky. Okay? So, first and foremost, we need to remember that for factoring, a lot of times we are talking about standard form. Now, I'm writing standard form here a little bit differently than how you might be used to seeing it, because I'm taking into account that these terms can be either positive or negative. So, what are some of the biggest factoring hints that we have? Well, the first one is you have to have a clear memory on what the signs mean. So when we're going to factor, the first thing you want to do is you want to look at the coefficient to your square term. So you want to ask yourself, is the coefficient to my x squared term greater than 1 or equal to 1? Now, that right there is going to dictate how you are going to factor. Okay? So, the biggest things that you can pay attention to is that first, if you are equal to 1, so your first idea is that if you equal 1, then you can go straight into the factors x plus or minus your number, and so on and so forth. Okay? However, if you're greater than 1, okay, so if you're greater than 1, then you want to use what some call the AC method, or what others call bottoms up. Okay, so you would want to use one of those two methods, and we'll talk about those in just a second here. Now, once you've determined what's going on with your coefficient, you need to kind of determine what the signs of your factors are going to be. So there's a couple things that you have to remember here. Okay, so the first thing that you have to remember is that the sign of the C term tells you which options you have. Now, what do I mean by that? I mean, we have a couple of different ideas. First, you can have positive times positive, which gives you that positive result. So if this is a positive back here, then one such option could be that your two factors are positive, thus giving you the positive result. Another such factor you could have is that negative times negative will also give you a positive result. Now, if your factor back here is negative, then we have that a positive times negative equals negative. So we have three different options that we can choose from, and it's all going to be determined on what this back sign is. Okay, so the back sign tells you which options you have to pick from. Well, your middle sign is going to tell you a little something different. Okay, so your middle sign here, this middle one, this is going to tell you which option must be used. Okay, so the back sign tells you what your three choices are, or which of your choices you have. This middle sign here tells you which option you have to use. So if the back sign, say, was positive, then we have these two choices here for positive, so this negative choice down here would not be there. If this middle sign here then was negative, you would use the negative negative option. Okay, if it was positive, you'd use the positive positive option. If this back sign here is negative, then you have to use this positive negative option regardless of this sign. Now there's another thing that this sign tells you, and what it tells you is that if the option used was negative times positive equals negative, then the middle sign tells you the sign of the bigger factor. So what does that mean? Well, that means, okay, that if your middle sign was positive, then your bigger factor is positive. If the middle sign was negative, the bigger factor is negative. But that rule only holds true if we are using the negative times positive option. Okay? So if you kind of keep some of these rules and ideas in mind when you are working with your factoring, it's going to make factoring a little bit easier. Okay? Alright, so let's do a couple examples so that you can kind of see these different rules and ideas in play. Okay? So, first and foremost, what do we have? Well, we have x squared minus x minus 12. So remember, the first thing you want to look at is you want to look at the coefficient of the x squared term. Now in this case my coefficient is 1. So here we would say my a equals 1. So therefore we can go straight into the factors. So what I would do is first I would then look at the sign. So I already know I can go straight into the factors. So the second thing I need to look at is I need to look at the signs of the factors. So again, remember, this back term here tells you what your options are. Okay, so the sine of the C term is negative. So that means your factors are going to be, so you have to use positive times negative to give you that negative result. Okay. Now, the other thing that we know is we know the sine of the B term is negative. So this means that the bigger factor is negative. Okay, so that's everything that tells us. So now, how do we actually factor? So the third thing is now we're going to factor. Okay, so the methods we need that is we need to have factors of 12 that add to negative 1. Okay, now don't forget this is a negative 12. But we're looking at the factors of 12 that are going to add to negative 1. Okay, so that is what our goal is. So one of the things that you can do is we can simply look at 12 and we can list all of their factors. So I know that I have 1 and 12, I've got 2 and 6, and I have 3 and 4. Now here's the other thing that I know. I know the bigger factor has to be negative. So notice I made my columns here, and on this right hand side are all of my bigger factors. And so what do I know about them? Well, I know that each of these has to be negative, which means my smaller factors are all positive. Now with that being said, if I combine these together, okay, what's going to happen is I have 1 minus 12 gives me negative 11, 2 minus 6 gives me a negative 4, 3 minus 4 gives me negative 1. So when I'm looking at these, I want negative 1. The only factor pair that does that is 3 and 4. Therefore, I can open a parenthesis and I have x, I have plus 3, close it, and then I have x minus 4 and close it. And this would be your factored result. Pretty simple. Okay. Alright. Now what happens if we want to factor this one? Okay, so again, we have to look at your first term. So the first thing we want to do is we want to look at the coefficient of the x squared term. Now in this case we have that a is 2. So we want to use a different method in order to factor. Okay, so what I'm going to show you is I'm going to show you bottoms up. So because a is 2, we're going to use bottoms up as the method of factoring. Now with that being said, the second thing that we need to look at is we need to look at the sines of the c term. Okay, so we're looking at this one, and this sign tells us that we must use positive times negative equals negative. The third thing that we have to look at is we need to look at the sine of the b term. So this sign here is going to tell us that the bigger factor is positive. Okay, so that's what we know so far. So now we need to use the bottoms up method. So bottoms up method says this. So we're going to go ahead and start our factoring. So with the bottoms up method, the first thing that we have to do is we have to take a times c. Well, my a is 2, so this is 2 times my c is negative 21. And we got to multiply those together. So we have negative 21 times 2 should be a negative 42. Okay. Now the second thing that we need to look at is we need to find the factors of 42. So again, we could make ourselves a factor tree. And so I want factors of 42. So first and foremost, I know that I have 1 and 42, and I know that I have 2 and 21. So then you need to look at what else do we have. Well, I've got 3 and 14. And I have 6 and 7. Now, the other thing that I know is I know that I'm using positive and negative as my factors, and the bigger factor is positive. So again, I made my list so that I had all of my big ones on one side and all my smalls on the other. And so here I'm going to go ahead and put in that all of these big numbers here are positive. So we have positives on this side, which means we have negatives for our smaller factors. Now we need a combination that when added together we get positive 1. Okay, so we need factors of 42. So now we need to look at when added, give positive 1 as a result. So I have 42 minus 1 is going to give me 41. I have 21 minus 2 is going to be 19. I've got 14 minus 3 gives me 11, and I have 7 minus 6 gives me 1. So again, I found my factors that work. So the way bottoms up works is, after you figure out what your factors are, now you have to do what's called set up the bottoms up. What that means is that we are going to set our factors up so that we have x plus or minus your factor divided by a. And we're going to do that for each factor. So here we're going to look at, I have negative 6, so this is going to be x minus 6. And then if you remember here from a minus c, my a was 2, so this is 6 over 2. I then have to do my other, so this is going to be x plus, and it's 7 over 2. Once you set it up, the next thing that you have to do is you have to reduce the fractions. 6 over 2 will reduce, so this becomes x minus 3. And then 7 over 2 does not reduce, so it's still 7 over 2. The last thing we do is we do bottoms up. In other words, take a shot. So think about if you're taking a shot, you grab the shot and you flip your head back, right? Bottoms up, shot glass goes up. Well, it's the same thing here. Anything left in your denominator has to bottoms up and become the coefficient to your variable term. So in this case, you're going to bottoms up any remaining denominators and rewrite your factors. And so here this becomes x minus 3 times 2x plus 7. And this was the result we were looking for. Okay? Pretty cool, bottoms up. The last type of factor that I wanted to look at real quick is what happens when you have 4 terms. So 4 terms is a very special factor. So this means we are going to do what's called the grouping method. The grouping method says you're going to group 2 terms together, pull out a GCF, then repeat with the remaining 2 terms. So we're going to go ahead and we're going to look first at these first 2 terms. So I am looking just simply at 3x cubed minus 4x squared. So I have 3x cubed minus 4x squared. When I group them together, notice the only thing that's in common with them is going to be this x squared. So I'm going to go ahead and pull out that x squared term, which is going to leave behind 3x minus 4. Now once you do that, you have to do the remaining terms. So here my remaining terms were negative 21x plus 28. So again, here I want to group. So the first thing I want is, my goal is to create this factor. Okay, so once you do your grouping, you want to create this factor in the second group. And you'll see why once we do that. So here, the first thing I would do is I would for sure pull out a negative. And then between 21 and 28, what's in common is going to be a 7. So when I pull that out, I am left with a 3x, and I'm left with a minus 4. So we need to put it all together. So we started with the 3x cubed minus 4x. So here we group that down to say x squared times 3x minus 4. And then we have the back half, minus 7 times 3x minus 4. So what you want to do from here is you are now going to group the terms on the outside, and you're going to write the factor, which is your parentheses, only once. So I'm going to group my terms on the outside. So I'm going to have x squared minus 7, and then I'm going to write my factor only once, 3x minus 4. And this is the factor term that we were looking for. So there you have kind of a snapshot reminder on 3 different examples using different methods for factoring. If you have any questions or need additional examples, please let me know. Otherwise, be creative, follow your rules, see what you can do, and I'll see you next time.